Imagine, if you will, a quiet room. The lights are low, and the world outside has begun to fade into the soft, velvet shadows of evening. You are safe. You are still. But even in this moment of absolute rest, something is moving. Somewhere out in the vast, cold reaches of the void, and even here, within the very air of your room, light is racing. It moves at a pace that defies human comprehension, 670 million miles per hour. It is a velocity so extreme that nothing we have ever built, no rocket we have ever fueled, and no particle we have ever accelerated can even begin to catch it. It is the universe's ultimate boundary. For a long time, we thought this was just a quirky trait of light itself. We thought light was simply the fastest thing around. But then, a brilliant mind named Richard Feynman looked deeper into the clockwork of reality and found something startling. He discovered that the speed of light isn't just about light. It is the speed of reality. It is the maximum rate at which the universe can update itself. It is the heartbeat of causality. Every atom that makes up your body, every firing neuron that creates your thoughts, is bound by this invisible cosmic limit. If this limit were to break, the very fabric of existence would come unraveled. Before we dive into the deep secrets of how space and time are stitched together, I invite you to settle in. If you find peace in these journeys through the stars and the hidden laws of nature, please consider subscribing to the Sleepy Academy. Your support helps us keep this sanctuary of learning and relaxation alive. Now, let the weight of the day lift from your shoulders. Take a deep breath. Let us begin our journey through time. The hillside of Florence. We begin our story in the year 1638, on a dark, quiet hillside just outside the city of Florence. The air is cool, and the stars above are bright and steady. A man stands there, clutching a covered lantern. This is Galileo Galilei. He is old now, but his mind is as sharp as ever, and he is haunted by a question. How fast does light move? Does it happen all at once, in an instant? Or does it take time to travel from one place to another? To find the answer, Galileo has organized a simple, elegant experiment. He has sent his trusted assistant to a distant hill, miles away, equipped with an identical lantern. The instructions were precise. Galileo would uncover his light. The moment the assistant saw the flash across the valley, he would uncover his own. Galileo would then measure the time it took for the light to make the round trip. It was a beautiful plan. It was logical. It was perfect. But the result was a mystery. No matter how far apart they stood, the light always seemed to return the very instant Galileo uncovered his lantern. To his eyes, light appeared to cross the valley in 0 time. He tried again with faster reflexes. He tried with greater distances. But the result never changed. Galileo was forced to conclude that if light had a speed, it was so incredibly fast that human perception could never catch it. He suspected it wasn't instantaneous, but he lacked the tools to prove it. He was trying to measure a heartbeat with a calendar. The problem of scale. Galileo's failure wasn't a failure of logic, it was a problem of scale. To understand why, we have to look at the numbers. Light travels at nearly 300,000 kilometers every single second. In the time it takes you to blink, light could circle the entire Earth 7 times. Galileo was trying to measure a delay of a few millionths of a second using a human brain that takes a quarter of a second just to react. The signal he was looking for was a tiny grain of sand buried under a mountain of noise. To catch the speed of light, humanity needed a bigger stage. We needed a distance so vast that even light would be forced to show its delay. We had to look away from the hills of Italy and toward the heavens, the moons of Jupiter. The breakthrough finally came in 1672 at the Paris Observatory. A young Danish astronomer named Ole Irmer was tasked with a routine job tracking the orbital motions of Jupiter's moons. Specifically, he was looking at Io, a small volcanic world that circles the giant planet with clockwork regularity. Astronomers used Io as a cosmic clock. They would time exactly when it disappeared into Jupiter's shadow and when it re-emerged. But as the months passed, Irmer noticed something strange. The clock was drifting. When the Earth moved closer to Jupiter in its orbit, Io's eclipses seemed to happen a few minutes earlier than predicted. When Earth moved to the far side of the Sun, away from Jupiter, the eclipses arrived late. The discrepancy wasn't large, only about 22 minutes over the course of a year, but it was consistent. Other scientists thought the math was wrong. They thought Io's orbit was simply irregular. But Irmer had a different idea, a revolutionary idea. He realized the eclipses were happening exactly on time. What was changing was the distance the light had to travel to reach Earth. When we were closer, the news of the eclipse reached us faster. When we were farther away, the light had to bridge a massive gap, and that took time. In 1676, Irmer announced his discovery. Light was not instantaneous. It had a finite, measurable speed. His calculations put that speed at about 220,000 kilometers per second. While his number was off by about 26% due to the imperfect measurements of the time, the impact was profound. For the first time, humanity realized that we are always looking into the past. The sunlight hitting your skin right now left the sun 8 minutes ago. The stars you see at night might have died thousands of years before you were born. We live in a patchwork of history, where every distance is a measurement of time, refining the number. As the centuries turned, the quest for precision intensified. In 1728, James Bradley discovered stellar aberration, a slight shift in the position of stars caused by the Earth's own movement through space. This allowed him to calculate the speed of light to within 1% of the modern value. Then came the era of the machines. In 1849, Hippolyte Fizeau built a clever device using a rapidly spinning toothed wheel and a distant mirror. By timing how fast the wheel had to spin to block the returning light, he brought the measurement into the laboratory. Shortly after, Foucault improved the design using a rotating mirror, confirming that light moved at the same incredible speed whether it was traveling across the solar system or across a room. By the late 1800s, we had the number 299,792 kilometers per second. It was a constant that appeared everywhere in the equations of electricity and magnetism. But as the number became more precise, a new and deeper mystery began to emerge. If light was a wave, what was it waving through? The ghostly ether. At the time, every wave we knew needed a medium. Sound waves need air. Ocean waves need water. It seemed impossible for a wave to travel through nothing. Scientists proposed that the entire universe was filled with an invisible, weightless substance called the luminiferous ether. This ether was thought to be a cosmic sea that stayed perfectly still while the planets and stars moved through it. If this ether existed, we should be able to feel the wind of it as the Earth plowed through space at 30 kilometers per second. This led to the most famous failed experiment in history. The Michelson-Morley Mystery. In 1887, Albert Michelson and Edward Morley built an incredibly sensitive machine called an interferometer. It used mirrors to split a beam of light into two paths, one traveling in the direction of Earth's motion and one traveling perpendicular to it. If there was an ether wind, the two beams should return at slightly different times. They floated their massive stone apparatus on a pool of mercury to keep it perfectly still and began to measure. They waited. They rotated the machine. They measured in the morning and at night. They measured in the summer and the winter. The result was always the same: nothing. The speed of light was identical in every direction. There was no ether wind because there was no ether. This discovery threw the world of physics into a panic. If there was no medium, how did light move? And why was its speed always the same, no matter how fast the observer was moving? It would take a young clerk in a Swiss patent office to realize that the problem wasn't with light, it was with our understanding of time and space itself. The year is 1905, and the world is on the precipice of a silent revolution. While the great cities of Europe are bustling with the clatter of horse-drawn carriages and the early chugging of steam engines, a 26-year-old clerk named Albert Einstein sits in a quiet office in Bern, Switzerland. His job is to review patent applications for clocks and synchronizing devices, a task that forces him to think deeply about the nature of time itself. He is not a famous professor. He is not surrounded by expensive equipment. He is armed only with his imagination and a persistent nagging question that has haunted him since he was 16. What would happen if I could ride alongside a beam of light? In the classical world of Isaac Newton, the answer seemed simple. If you were in a carriage moving at 10 miles per hour, and you threw a ball forward at 10 miles per hour, an observer on the ground would see that ball moving at 20 miles per hour. Speeds added up. They were relative to one another. But as Einstein sat at his desk, staring at the blueprints for synchronized clocks, he realized that light refused to follow these rules. Light was the rebel of the universe. The bold choice. Einstein decided to take a leap of faith that no other scientist had the courage to take. He decided to assume that the speed of light was not just a number, but an absolute law. He proposed that regardless of how fast you are moving, whether you are standing still on a train platform or racing through the stars in a futuristic ship, a beam of light will always approach you at exactly 299,792 kilometers per second. It does not matter if you run toward it or flee from it. The light will not slow down. It will not speed up. This sounds like a minor detail, but it is the crack in the foundation of everything we thought we knew. If light speed stays the same for everyone, then something else has to change. To keep that speed constant, the universe has to distort the very things we thought were fixed: space and time. This was the birth of special relativity, the idea that time is not a universal heartbeat, but a flexible fabric that stretches and folds depending on your movement. The stretching of seconds. Imagine you are lying in a comfortable bed on a high-speed train, moving through the night. Beside you is a clock that works using light. It bounces a single photon between two mirrors, one on the floor and one on the ceiling. Each time the photon hits a mirror, the clock ticks. To you, the light is simply moving up and down in a straight line. The tick of the clock feels perfectly normal. But now, imagine someone standing outside on the dark embankment, watching your train roar past at nearly the speed of light. To them, the light inside your clock isn't just moving up and down. Because the train is moving forward, the light has to travel in a long diagonal zigzag to catch the mirrors. To the person on the ground, the light has traveled a much longer distance than it did for you. And here is the heart of the mystery. Because light must always travel at the same speed, and it had a longer distance to cover for the observer on the ground, it must take more time to complete its journey. From the perspective of the person on the ground, your clock is ticking slower. Your heartbeat is slower. Your thoughts are slower. To them, you are moving through a world of thick, syrupy time, where every second is stretched like taffy. Time dilation in the real world. This phenomenon is called time dilation, and while it sounds like science fiction, it is a fundamental truth of our reality. It is happening to you right now, though on a scale so small it is impossible to notice. When you walk down a street, your time is flowing a billionth of a second slower than the time of the person sitting on a park bench. The universe is constantly adjusting its tempo. At everyday speeds, the effect is invisible. But as we move closer to that cosmic barrier, the speed of light, the stretching becomes dramatic. If you were to board a spacecraft and travel at 90% the speed of light, 1 year of your life would equal more than 2 years for those back on Earth. You would return to find your friends older than you, your children grown, while you had barely aged a day. The shrinking of space. But time is only half of the story. If the universe stretches time to keep light speed constant, it must also manipulate space. This is known as length contraction. As an object begins to approach the speed of light, it begins to physically shrink in the direction of its motion. Think of a long silver spacecraft resting on a launch pad. It is 100 meters long, but as it accelerates toward the stars, nearing the speed of causality, a stationary observer watching it zoom past would see it differently. At 99% of the speed of light, that 100-meter ship would appear to be only 14 meters long. It would look like a thin, compressed disk, a sliver of matter racing through the void. To the people inside the ship, everything looks normal. Their walls haven't moved. Their beds are still the same size. But to them, the universe outside has changed. The distance to the next star, which they thought was light years away, has physically shortened. The very fabric of space has folded inward, allowing them to bridge the gap in a way that seems impossible to those left behind. The union of space and time. Einstein realized that we can no longer think of space as a three-dimensional box and time as a separate ticking clock. They are fused together into a four-dimensional continuum called space-time. You cannot move through one without affecting the other. Every movement you make is a trade-off. If you are sitting perfectly still right now, you are moving through time at the maximum possible rate. All of your velocity is being spent on the dimension of time. But the moment you begin to move through space, even just to walk across the room, you divert a tiny portion of that velocity away from time and into space. The faster you move through space, the slower you move through time. If you could reach the speed of light, you would be moving through space so fast that your movement through time would stop entirely. To a photon, there is no such thing as time. A photon created in the heart of a distant star billions of years ago does not experience the passage of the eons. To the photon, the moment it is born and the moment it strikes your eye are the exact same instant. It exists in a state of eternal now, crossing the entire universe in what is, to it, zero time. The paradox of the muons. While Einstein's theories were elegant on paper, they needed proof. That proof came from the very edges of our atmosphere in the form of tiny particles called muons. These particles are created when cosmic rays from deep space strike the upper layers of our air. Muons are unstable. They live for only a fleeting 2/millionths of a second before they decay into something else. Even traveling at nearly the speed of light, a muon should only be able to travel about 600 meters before it vanishes. Since they are created 15 kilometers up, they should never, ever reach the ground. And yet, our detectors at sea level are constantly being struck by them. How do they survive? The answer lies in time dilation. Because the muons are moving so fast, their internal clocks slow down relative to ours. Their 2/millionths of a second is stretched out into a much longer duration in our world. From the muon's perspective, the distance it has to travel, the 15 kilometers of atmosphere, shrinks down to a few hundred meters due to length contraction. Both the stretching of time and the shrinking of space work together to allow these ghost-like particles to reach us. They are living proof that Einstein was right. The infinite wall. As we contemplate these distortions, a question arises. Why can't we just keep going? If moving faster makes time slow down and space shrink, why not just push a little harder and break through the 299,792 kilometer per second barrier? This is where the universe reveals its ultimate defense. As an object accelerates, it doesn't just experience changes in time and space, it experiences a change in its very essence. In the old world of Newton, we thought mass was a fixed thing. A kilogram was a kilogram. But Einstein showed us that mass and energy are two sides of the same coin. When you put energy into an object to make it go faster, not all of that energy goes into speed. As you get closer and closer to the speed of light, more and more of that energy is converted into mass. The object becomes heavier in terms of its resistance to movement. To push a single electron to the speed of light would require more energy than exists in all the stars of the galaxy. To push a human being, or a ship, would require an infinite amount of energy. The speed of light is not just a limit because it's fast. It is a limit because it is an infinite wall. To reach it, you would have to become infinitely heavy, and you would need the entire power of the universe to give you that final, tiny nudge. The universe has built its laws so that no matter how much we fuel our engines, we are forever destined to stay on this side of the light. A world of perspective. Take a moment now to consider the profound strangeness of this reality. Every person you see, every bird in the sky, every car on the road is living in their own slightly different version of time. There is no single now that everyone shares. If a star explodes in a distant galaxy, the time it happens depends entirely on how fast you are moving and where you are standing. We are like travelers in a vast, foggy landscape, each carrying our own lantern of time, seeing only the ripples of causality that reach us. The speed of light is the tether that keeps the universe from descending into chaos. It ensures that cause always leads to effect, even if the timing of those events seems to shift and shimmer like a mirage. Einstein's work was more than just math. It was a philosophy of existence. It taught us that our senses are limited, that the world is far more flexible and mysterious than we ever dared to dream. As you rest now, let the idea of these melting clocks and shifting distances wash over you. You are part of a four-dimensional masterpiece, a dance of light and shadow where every second is a gift of the cosmic geometry. The looming question. But even with Einstein's genius, the why remained. We knew light was the limit. We knew it bent time and warped space. But what was the hidden mechanism? What was the invisible hand that turned energy into mass and stopped our clocks at the boundary of the light? To find that answer, we must leave the quiet patent office of Bern and move forward in time to a new generation of thinkers. We must look toward the quantum world, where particles don't just move, they exist in a blur of possibilities. We must look toward the man who would find the rhythm of the universe's heartbeat. Our journey is only beginning. We have seen the hilltop lanterns of Galileo and the drifting moons of Armare. We have felt the stretching of time in the Swiss patent office, but the deepest secret of all is still waiting to be uncovered. The secret of why reality has a speed at all. As you settle deeper into your surroundings, imagine the world around you beginning to dissolve. The solid walls, the heavy furniture, even the air you breathe, imagine them breaking down into trillions upon trillions of tiny vibrating points of energy. This is the quantum world. It is a place where the common sense of our daily lives no longer applies. In our world, an object is either here or it is there. In the quantum world, a particle can be in many places at once, a shimmering cloud of maybe until the moment it is observed. This chapter of our story belongs to one of the most original thinkers in the history of science, Richard Feynman. Born in New York in 1918, Feynman was a man who refused to see the world through the dusty lens of old textbooks. From the time he was a young boy fixing radios in his neighborhood, he had a curious mind. A mind that wanted to pull reality apart to see how the gears turned. He didn't just want to know the names of things, he wanted to know how they worked. The problem with the old rules. By the time Feynman reached university, the world of physics was in a state of quiet crisis. Einstein had given us the rules for the very large: planets, stars, and the fabric of space-time. Other geniuses, like Niels Bohr and Werner Heisenberg, had given us the rules for the very small, the strange, jumpy behavior of electrons. But when scientists tried to combine these two sets of rules, the math broke. Specifically, they were struggling with a theory called quantum electrodynamics, or QED. This was the study of how light and matter interact. At its heart, it was an attempt to explain how an electron, a tiny piece of matter, could feel the force of light. The equations they used were beautiful, but they had a fatal flaw. Whenever a physicist tried to calculate the energy of a single electron, the answer came back as infinity. In the world of science, an answer of infinity is a disaster. It means your theory is broken. It's the universe's way of saying, you've missed something fundamental. If an electron truly had infinite energy, it would be heavier than the entire universe. It would collapse into a black hole the moment it was born. Yet, here we are, made of electrons that are light, stable, and very much finite. Feynman's visual revolution. While other physicists were drowning in pages of complex algebra, trying to find where the infinities were hiding, Richard Feynman did something radical. He stopped looking at the numbers and started drawing pictures. He realized that our brains aren't built to understand abstract equations, but they are very good at understanding stories. He began to visualize the interaction between light and matter as a dance. He imagined two electrons moving through space, and instead of some invisible force pushing them apart, he saw them tossing a particle of light, a photon, back and forth between them. Think of two people on ice skates. As one person throws a heavy ball to the other, the act of throwing pushes the first person backward. When the second person catches the ball, the impact pushes them backward as well. To someone watching from a distance, it looks like an invisible force is pushing the skaters apart. Feynman realized that this ball was the photon. Light was the messenger of force. The birth of the diagrams. These simple sketches became known as Feynman diagrams. They are more than just drawings, they are a map of reality. In a Feynman diagram, a straight line represents a particle of matter, like an electron. A wavy, squiggly line represents a particle of light, a photon. But here is where the story connects back to our cosmic speed limit. When Feynman drew these interactions, he realized he had to account for every possible way a photon could travel from one electron to another. In the quantum world, the photon doesn't just take the shortest path. It explores every path. It zigzags. It loops. It even seems to travel backward in time before moving forward again. This leads us to Feynman's most profound contribution: the path integral formulation, also known as the sum over histories. The path of all possibilities. Imagine you are standing at the edge of a vast, dark forest. You want to walk to a cabin on the other side. In our classical, everyday world, you would simply find the straightest, easiest path and walk it. But in the world of the quantum, you do not take just one path. You take every path. You walk the straight line. You walk the long way around the mountains. You walk in circles. You even walk to the moon and back before finally reaching the cabin. In Feynman's view, a particle traveling from point A to point B is actually taking every conceivable route through the universe simultaneously. This sounds like madness. How could a single photon be in a billion places at once, taking paths that make no sense? Feynman's answer was mathematical, but the essence is beautiful. Each of these paths has a phase. Think of it like a tiny rotating clock hand. As the particle travels, the hand of the clock spins. For the paths that are wild and nonsensical, the ones that loop out into deep space and back, the clocks all point in different directions. When you add them all up, they cancel each other out. The noise of the impossible paths vanishes into nothingness. But for the paths that are close to the straight line, the path we see in our world, the clocks all point in the same direction. They reinforce each other. They add up to create the reality we observe. The speed of light as a filter. This is the moment where we find the secret of the speed limit. Feynman's math showed that the speed of light is the balancing point for these paths. When you calculate the sum over histories for a particle, the paths that involve moving faster than the speed of light have a very special property. Their clocks spin so fast and so wildly that they always, without exception, cancel each other out perfectly. They interfere with themselves. The universe isn't a police officer standing over a particle saying, "You are not allowed to go faster than 299,792 kilometers per second." Instead, the universe is built in such a way that the faster-than-light paths simply don't survive the math. They are like ghosts that disappear the moment you try to look at them. They are mathematically allowed to exist in the calculation, but they contribute exactly zero to the final result of reality. The speed of light, therefore, is not a wall. It is a filter. It is the boundary where the quantum maybes become physical is. It is the maximum rate at which these waves of possibility can add up to create a solid event. The ghostly virtual particles. As Feynman refined his diagrams, he discovered another strange inhabitant of the quantum forest: virtual particles. These are particles that pop in and out of existence so quickly that they can never be seen directly. They exist in the tiny gaps of time, permitted by the uncertainty principle. These virtual particles are the ones that actually do the work of the universe. When two magnets pull toward each other, they are exchanging a storm of virtual photons. These virtual messengers are allowed to break the rules of the classical world. For a trillionth of a second, they can have impossible amounts of energy. But even these rule breakers are bound by the ultimate law of causality. While a virtual particle might seem to jump across a gap in an impossible way, the total information of the system, the message that tells one magnet to move toward another, can never travel faster than the speed of light. The quantum world is a place of wild freedom, but that freedom is always contained within the ironclad walls of the cosmic speed limit. Feynman's irreverent genius. Richard Feynman was often asked how he could be so sure of these strange ideas. He would usually smile and say, "If you think you understand quantum mechanics, you don't understand quantum mechanics." He knew that the universe was far weirder than we could imagine, but he trusted the results. His theory of KED, built on these drawings and paths, eventually became the most precisely tested theory in human history. It can predict the behavior of an electron with an accuracy equivalent to measuring the distance from New York to Los Angeles to within the width of a single human hair. It is, for all intents and purposes, the truth. And the truth that Feynman found was that we live in a world of limits that are also our foundations. We are bound by the speed of light, because that speed is what allows the sum of the universe to be something instead of nothing. The harmony of the two worlds. As you reflect on this, see how the pieces are starting to fit together. Einstein showed us the how space and time bend to keep light's speed constant. Feynman showed us the why the very nature of quantum paths requires this limit to exist. We are beginning to see that the speed of light is not just about light. It is the fundamental tempo of existence. It is the rate at which the clocks of the universe sync up. It is the heartbeat of the void. Without this limit, the quantum sum would never settle. The forest of possibilities would be a chaotic storm where cause and effect had no meaning. Feynman's work earned him the Nobel Prize. But more importantly, it gave us a way to visualize the invisible. He showed us that even in the heart of an atom, there is a structure, a rhythm, that mirrors the vastness of the cosmos, the looming mystery of mass. But there was still one piece missing. Feynman had explained how light and matter interact, but he hadn't fully explained why some things have mass and others do not. Why does a photon have zero mass, allowing it to fly at the speed of light, while an electron has a small amount of mass, forever trapping it below that barrier? To answer that, we have to look at the field. We have to understand that space is not empty. It is a thick, invisible ocean that every particle must swim through. And in that ocean, there is a drag that gives us our weight, our substance, and our limits. As we move toward the next part of our journey, let your mind drift like a particle in Feynman's forest. You are not just one path, you are a collection of possibilities, held together by the gentle, steady hand of the light. You are safe within the limits of the universe. Preparation for the field. We have seen the hillside of Galileo. We have seen the office of Einstein. We have seen the diagrams of Feynman. Now we must go even deeper. We must look at the Higgs field, the cosmic molasses that gives the universe its weight. We must understand how the speed of light interacts with gravity, the force that shapes the stars themselves. Rest now, knowing that the laws of physics are watching over you. They are as steady as the stars and as intricate as the atoms. The universe has a speed, a tempo, and a limit, and you are a perfect part of its grand design. As you drift further into relaxation, imagine for a moment that you are submerged in a vast, perfectly clear ocean. You cannot see the water, but you can feel it. When you try to move your hand quickly, you feel a resistance, a gentle, steady push against your palm. If you were to release a bubble of air, it would race toward the surface, but a heavy stone would sink slowly, fighting the density of the liquid every inch of the way. This is a perfect metaphor for the universe. For centuries, we believed that empty space was truly empty, just a void, a nothingness between the stars. But modern physics has revealed a much stranger truth. Space is not empty. It is filled with invisible fields, like a cosmic fabric stretched tight across the dimensions. And the most important of these fields for our story is the Higgs field. The Higgs field is like a cosmic molasses that permeates every corner of the universe. It is everywhere. It is inside your room, inside your body, and in the dark reaches between the furthest galaxies. And it is this field that determines which particles are allowed to fly at the speed of light, and which are forced to trudge along, weighted down by mass. The mystery of the weightless particle. Think back to our hero, the photon. A photon is a particle of light, and as we have discussed, it always moves at the maximum speed of the universe, 299,792 kilometers per second. Why? Why does light get to move so fast while we, made of atoms and electrons, are stuck in the slow lane? The answer is that photons are massless. In the language of the Higgs field, Photons are like perfectly streamlined fish. They swim through the cosmic molasses without catching any of it. The Higgs field has no effect on them. Because they experience zero drag, they are naturally propelled at the maximum possible speed of causality. To a photon, the universe is a frictionless playground. But other particles, like the quarks that make up your protons or the electrons that orbit your atoms, are different. They are sticky. As they move through the Higgs field, they interact with it. They get tangled in the molasses. This interaction, this invisible drag, is what we experience as mass. What is mass, really? We often think of mass as stuff, as the amount of matter inside an object. But the Higgs field teaches us that mass is actually a relationship. It is a measurement of how much a particle is fighting against the background of the universe. Imagine two people walking through a crowded room. One person is a famous celebrity, and the other is a complete stranger. The stranger can walk across the room in a straight line, completely unbothered. They move quickly, like a photon. But the celebrity is constantly being stopped. People reach out to shake their hand, to ask for a photo, to strike up a conversation. The celebrity moves slowly, hindered by their interactions with the crowd. To an observer, the celebrity appears heavier. They have more mass because they are more connected to the field of people around them. This is why you cannot reach the speed of light. Every single particle in your body is a celebrity to the Higgs field. They are constantly interacting with the invisible background of space. To move you at the speed of light, we would have to somehow turn off your connection to the Higgs field, making you invisible to the universe's molasses. But if we did that, the very forces that hold your atoms together would dissolve. You would cease to be you and become a burst of pure, massless energy. The speed of light as the natural state. There is a beautiful realization hidden here. In the absence of the Higgs field, everything in the universe would move at the speed of light. Mass is not the default state of existence. It is a latecomer. In the very first moments after the Big Bang, before the Higgs field switched on, all particles were massless. They all raced through the newborn cosmos at the speed of light in a chaotic, blinding dance of pure velocity. It was only when the universe cooled and the Higgs field emerged that mass was born. The molasses thickened, the particles slowed down, and for the first time, matter could settle. Protons could form, atoms could bond, planets could coalesce. Mass is the brake that the universe applied to itself so that complexity could exist. We are slow because we are complex. We have weight because we are substantial enough to interact with reality. The infinite resistance. Now, let us return to that infinite wall we discussed with Einstein. You might wonder, if I have enough fuel, can't I just push through the molasses? Here is where the math of Einstein and the fields of the quantum world meet in a spectacular display of cosmic enforcement. As you add energy to an object to make it go faster, you are essentially trying to shove it through the Higgs molasses with more force. But Einstein showed us that energy and mass are the same thing, Letty Endless Lawler MC2 DAS. When you pump energy into a particle, that energy itself begins to interact with the Higgs field. It's as if the celebrity in our crowded room starts carrying more and more luggage. The faster they try to go, the more stuff they are carrying, which makes the crowd even more interested in stopping them. The faster you move, the heavier you become, and the harder the Higgs field pushes back. By the time you reach 99.999% of the speed of light, your mass has increased so much that you are effectively as heavy as a mountain, then a planet, then a star. To bridge that final tiny gap to 100%, you would need more energy than exists in the entire universe. The Higgs molasses becomes like solid concrete. The speed of light is the point where the resistance becomes absolute. The Higgs boson, a ripple in the deep. For decades, the Higgs field was just a beautiful idea, a mathematical trick to explain why we aren't all flying apart at light speed. But in 2012, at the Large Hadron Collider in Switzerland, scientists finally proved it was real. They did this by smashing protons together at nearly the speed of light, creating a tiny ripple in that invisible field. That ripple is a particle called the Higgs boson. It only exists for a fraction of a second, but its discovery confirmed that the cosmic molasses is real. It confirmed that the reason you are lying here, feeling the weight of your body against the bed, is because you are intimately connected to the very fabric of space. The gravity connection. But mass doesn't just create drag, it creates a curve. And here we meet the largest force of all, gravity. Einstein's general relativity tells us that anything with mass, anything that interacts with the Higgs field, doesn't just sit in space. It bends it. Imagine placing a bowling ball on a trampoline. The fabric of the trampoline curves downward. If you place a marble on the edge, it will roll toward the bowling ball. Shutterstock. Explore. This is what your body is doing to the room right now. You are a small, gentle curve in the fabric of the universe. The Earth is a much larger curve, holding you down. And the Sun is a massive, deep well that keeps the entire solar system in its grip. But what about the speed of light? It turns out that gravity, too, is bound by the speed of causality. If the Sun were to suddenly vanish, the Earth would not immediately fly off into the dark. We are 8 light minutes away from the Sun. Because gravity is a ripple in the fabric of space, and those ripples can only move at the speed of light, we would continue to orbit an empty spot in the sky for 8 minutes. We would see the Sun disappear and feel the release of gravity at the exact same moment. The cosmic speed limit as a safety feature. As you listen to this, you might start to see the speed of light as a kind of cosmic safety feature. If gravity or light could move infinitely fast, the universe would be a place of instant, violent chaos. A star exploding on the other side of the galaxy would affect us the very microsecond it happened. There would be no distance. Everything would be connected to everything else, all at once. The speed of light provides the universe with buffer room. It allows events to happen in isolation. It gives us the gift of time. Because the speed of light is finite, the universe is vast. It has a history. It has a past that stays in the past and a future that takes time to arrive. The speed of light is the reason we can have a coherent story. The weight of existence. Let yourself feel the weight of your limbs. Feel the drag of the Higgs field as you breathe. It is a comforting thought. You are not a ghost drifting through a void. You are a solid, meaningful part of a grand structure. Your very weight is proof that you belong to the universe, that you are woven into the same field that gives mass to the stars. You are slow, yes. You are bound to the Earth. You cannot race alongside the photons. But in your slowness, you have gained something the photon will never know. You have gained time. You have the ability to experience a second, a minute, a year. You can remember the past and dream of the future. The photon racing at the limit is frozen in a single, timeless moment. But you, weighted down and moving slowly, get to experience the full, rich tapestry of life. The horizon of the black hole. As we contemplate mass and gravity, we must eventually look at the places where these forces become so strong that even light loses its battle. We must look at the black hole, the place where the speed of light is no longer enough to escape. In the next part of our journey, we will travel to the edge of the event horizon. We will see what happens when the curve of space becomes so steep that the infinite wall of light speed is turned inward on itself. We will see the place where time stops and the laws of physics are pushed to their absolute breaking point. But for now, stay here in the safety of the shallow curves. Feel the gentle molasses of the Higgs field holding you. You are exactly where you are supposed to be, moving at exactly the speed you were meant to move. The rhythm of the vacuum. Before we close this chapter, consider the silence of the vacuum. Even in the deepest parts of space, where there are no stars and no planets, the fields are still there. The Higgs field is there. The electromagnetic field is there. The clocks that Feynman talked about are still spinning in the dark. The universe is never truly empty. It is a humming, vibrating symphony of fields, and the speed of light is the conductor's baton, setting the tempo for every vibration. Whether it is a tiny electron or a massive galaxy, everything follows the beat. Rest in that rhythm. Let the heartbeat of the universe become your own. You are a part of the field, a ripple in the molasses, a curve in the space. You are the universe experiencing itself at a human pace. As we move into the fifth stage of our journey, we must travel to the most extreme environments in the cosmos. We have explored how the speed of light dictates the flow of time and the weight of matter, but now we must confront the places where gravity becomes so absolute that even the universe's fastest messenger is held captive. We are traveling to the edge of the abyss, the event horizon and the light that never returns. In the previous chapters, we learned that light is the ultimate escape artist. It is massless, swift, and moves at a constant, unyielding pace. But even the swiftest runner can be trapped if the ground beneath them is moving faster than they can sprint. To understand the true power of the cosmic speed limit, we must look at the phenomenon of the black hole, a place where the geometry of the universe becomes a one-way street. Imagine you are drifting through the dark, cold vacuum of deep space. Far in the distance, you see a circle of absolute nothingness. It is not just dark, it is a hole in the sky, rimmed by a flickering, glowing halo of gas and dust. This is a black hole. It is a region of space where matter has been crushed into a point of infinite density, yet creating a gravitational pull so intense that the escape velocity exceeds the speed of light. The concept of escape. To understand why light gets trapped, we must first think about what it means to escape. If you throw a ball into the air on Earth, it eventually falls back down. If you throw it harder, it goes higher. If you could throw that ball at 11 kilometers per second, the Earth's escape velocity, it would never come back. It would break free of Earth's grip and fly into the stars. The Sun is much larger, and its grip is much stronger. To escape the Sun, you would need to travel at 617 kilometers per second. Now, imagine an object so dense and so massive that its escape velocity is 300,000 kilometers per second. This is the threshold, because nothing in the universe can travel faster than light, and anything that crosses into this region is permanently, mathematically, and physically trapped. There is no engine powerful enough, no fuel potent enough, and no signal fast enough to bridge the gap back to our world. The event horizon, the point of no return. The boundary surrounding this abyss is called the event horizon. It is a beautiful and terrifying name. It is called the event horizon because it is the limit of our knowledge. Anything that happens inside that boundary can never affect the universe outside. The news of those events, carried by light, can never reach us. Think of the event horizon not as a solid wall, but as a waterfall. Imagine you are in a boat on a river, and ahead of you is a massive, roaring drop-off. As long as you stay far enough back, you can row against the current and stay safe. Yes, but as you get closer to the edge, the water moves faster. At some point, the water is moving faster than you can possibly row. Even if you have a world-class engine, if the river is flowing at 300,001 kilometers per hour, and your top speed is 300,000, you are going over the edge. In a black hole, space itself is flowing inward. At the event horizon, space is falling into the singularity at exactly the speed of light. Because light can only move at the speed of light, it becomes like a runner on a treadmill that is moving too fast. The light runs outward with all its might, but it stays perfectly still relative to the horizon. It is frozen in a desperate, eternal struggle to escape a current that is simply too strong. The bending of the path. As you approach this horizon, the sum over histories we discussed with Richard Feynman takes a dark turn. Remember that a photon explores every possible path. Near a black hole, gravity is so strong that it bends the very fabric of space-time. The straight paths become curves. The curves become loops. If you were to stand a safe distance away and shine a flashlight near a black hole, you would see the beam of light curve around it like water around a drain. If you aimed it just right, the light would enter an orbit, circling the black hole forever in a ring of trapped radiation called the photon sphere. In this strange place, the light is literally chasing its own tail. If you were standing there, you could look straight ahead and see the back of your own head as the light from your hair circles the black hole and returns to your eyes. But if the light moves just a fraction of an inch closer, the curve becomes a spiral. The sum of all possible paths for that photon now leads to only one destination, the center. There is no longer a mathematical path that leads back to the outside world. The future of the photon has been rewritten by gravity. Time stands still. One of the most haunting effects of the light speed limit occurs at the very edge of the horizon. As we learned from Einstein, gravity slows down time. Near a black hole, this effect is magnified to the extreme. Imagine you are watching a brave astronaut descend toward the event horizon. As they get closer, you would see their movements begin to slow down. Their watch would tick once every minute, then once every hour, then once every year. The light reflecting off their suit would struggle to climb out of the gravitational well, losing energy and shifting into deep, dark red tones, a process called gravitational redshift. From your perspective, the astronaut never actually crosses the horizon. They seem to slow down more and more, becoming dimmer and redder, until they appear frozen in time, a ghostly statue hovering forever at the edge of the abyss. But from the astronaut's perspective, everything is different. They feel no change in time. They look at their watch and see it ticking normally. They cross the horizon in a few seconds, unaware that to the outside world, they have become a permanent part of the black hole's history. The singularity and the end of physics. Once the astronaut or the light crosses the horizon, the speed of light limit becomes a death sentence. Inside the black hole, the roles of space and time actually swap. In our world, you can choose to move left or right, up or down, but you cannot choose to move backward in time. Time is a one-way street. Inside a black hole, the center, the singularity, is no longer a place in space. It is a moment in time. Because gravity has warped the geometry of the universe so severely, all paths lead to the center. Moving away from the center would be like trying to move yesterday. It is physically impossible. Even if you turn your engines to 100% and aim them outward, you are still moving toward the singularity, because outward no longer exists in your future. At the very center lies the singularity, a point where the mass of 1,000,000 suns is crushed into a space smaller than an atom. Here, the density becomes infinite. The curvature of space-time becomes infinite. And here, the speed of light is no longer a useful concept, because the very fabric of space and time has been torn apart. This is the place where our current understanding of the universe ends. The protection of the limit. It might seem terrifying that such places exist, but there is a strange comfort in the speed of light. Because the limit is absolute, the secrets of the black hole remain hidden. This is what physicists call cosmic censorship. The speed of light acts as a veil, protecting the rest of the universe from the naked singularities that would break the laws of physics. If information could travel faster than light, the chaos inside a black hole could leak out. The infinite math of the singularity could infect the rest of reality, making cause and effect unpredictable. But because light, and therefore causality, cannot escape, the black hole is a self-contained vault. It keeps its paradoxes to itself, allowing the rest of the universe to remain orderly and logical. The Hawking radiation. A tiny leak. For a long time, we thought black holes were perfectly black, forever silent. But Stephen Hawking discovered a tiny loophole, once again involving the quantum sum over histories. In the vacuum of space, virtual particles are constantly popping in and out of existence. Usually, they find each other and cancel out instantly. But at the very edge of the event horizon, something strange happens. Sometimes, one virtual particle falls into the black hole, while its partner escapes into space. Because the partner has escaped, it becomes a real particle. To pay for the energy of this new particle, the black hole must lose a tiny bit of its own mass. This process is called Hawking radiation. Over trillions upon trillions of years, a black hole will slowly evaporate, leaking its energy back into the universe as a faint, ghostly glow. Even the strongest gravitational trap in the universe eventually yields to the patient, persistent laws of quantum mechanics. The ultimate perspective. As you lie here, safe and still, let the vastness of this idea settle over you. The speed of light is the reason why the stars are far away, why the past is unreachable, and why the black holes are silent. It is the boundary that defines what is here and what is there. In our daily lives, we feel like we are in control of our surroundings. But on the cosmic scale, we are all just travelers on the edge of a great horizon. We are bound by the speed of causality, moving forward in time because the geometry of the universe requires it. The black hole is a reminder that the speed of light is not just a number on a page. It is the architect of existence. It builds the walls of the possible and the impossible. It ensures that your life has a sequence, a beginning, a middle, and an end. Resting at the edge. The terrifying beauty of the event horizon is that it represents the end of the road. But for us, sitting in the gentle curves of Earth's gravity, it is just a distant whisper. We are far from the abyss. We are in the realm where light travels freely, where we can see the stars and plan for tomorrow. Let your mind drift away from the intense gravity of the black hole and back to the soft, steady rhythm of your own breathing. You are not falling. Yet you are not trapped. You are supported by the very same space-time that black holes warp so violently. The fabric beneath you is stable. The light in your room is calm. In the next part of our journey, we will look away from the darkness of black holes and toward the light of the beginning. We will see how the speed of light shaped the birth of the universe and how it continues to guide the expansion of all that is. We will see how the limit of speed became the reason for the limit of our sight. But for now, rest. The speed of light is guarding the horizon. The laws of physics are holding the void at bay. You are safe in the slow, beautiful tempo of the world. As we move past the halfway point of our 18,000-word deep dive, we shift our gaze from the dark traps of gravity to the very beginning of everything. And to understand the speed of light is to understand the history of the universe, for light is the only true record keeper we have. The first light and the edge of the observable. Take a long, slow breath and imagine yourself floating in a space that has no stars, no planets, and no galaxies. Imagine a time before time was even measured. We are traveling back far beyond the age of the dinosaurs, far beyond the formation of our sun, to the very first moments of the universe's existence. At this stage, the speed of light wasn't just a limit, it was the storyteller. One of the most profound realizations in physics is that because light travels at a finite speed, every telescope is essentially a time machine. When you look at the moon, you see it as it was 1.3 seconds ago. When you look at the stars of the Big Dipper, you see them as they were decades or even centuries ago. The deeper we look into space, the further we look back into the past. But there is a limit to how far back we can see. A wall made of light itself. The Great Fog, in the earliest stages of the Big Bang, the universe was not the cold, dark place it is today. It was a searing, chaotic soup of energy and matter. It was so hot and so dense that atoms could not even form. Electrons and protons flew about in a wild, frantic dance. During this era, light was trapped. Even though a photon wants to move at 299,792 kilometers per second, it couldn't get anywhere. It was like a person trying to run through a dense, panicked crowd. Every time a photon tried to move, it immediately smacked into a free-floating electron and was knocked in a different direction. The universe was an opaque, glowing fog. No information could travel. No news could be sent. But as the universe expanded, it began to cool. The frantic dance slowed down. About 380,000 years after the beginning, the temperature dropped enough for electrons to finally settle down and pair up with protons. They formed the first simple atoms of hydrogen. Suddenly, the crowd vanished. The electrons were tucked away inside atoms, leaving the path clear. For the first time in history, light was set free. The cosmic microwave background, that first burst of light released billions of years ago, is still traveling through the universe today. It has been flying through the void for 13.8 billion years. And because the universe has expanded so much since then, that light has been stretched out. It is no longer visible to our eyes. It has shifted into the long, cool wavelengths of microwaves. This is what scientists call the cosmic microwave background, or the CMB. It is the afterglow of creation. It is a faint, steady hum of energy that fills every inch of the sky. If you could see in the microwave spectrum, the entire night sky would glow with a soft, uniform warmth. This light is the furthest thing we can ever see. It marks the surface of our observable universe. Because the speed of light is finite, we can only see as far as light has had time to travel since the beginning. This creates a bubble around us, a horizon. Beyond this bubble, there may be trillions of other galaxies and infinite stretches of space. But because the universe is only 13.8 billion years old, the light from those distant places simply hasn't reached us yet. They are effectively outside of our reality. The expanding bubble here is where the speed of light interacts with the most mind-bending concept of all, the expansion of space. You might think that if the universe is 13.8 billion years old, our bubble of visibility should be 13.8 billion light-years wide. But it isn't. It is actually about 46 billion light-years in every direction. How is that possible? How can we see something 46 billion light-years away if light only travels at a set speed? The answer is that space itself is stretching. Imagine you are an ant crawling across a rubber balloon. You are moving at your maximum speed, but while you crawl, someone is blowing up the balloon. Even though you've only been crawling for a minute, the spot where you started is now much, much further away than your little legs could ever have carried you. The light from the first atoms has been traveling toward us at its constant speed, but the space it was traveling through was growing. By the time that light finally hits our telescopes, the place it came from has been pushed nearly 50 billion light-years away. The universal speed limit versus the expansion. There is a common misunderstanding that nothing can move faster than light. But Einstein's rule actually says that nothing can move through space faster than light. Space itself is not bound by this rule. Space can expand at any rate it wants. In the very distant reaches of the universe, its galaxies are being pushed away from us so fast that the distance between us is growing faster than light can cross it. This doesn't mean the galaxies are breaking the speed limit. It means the fabric they are sitting on is stretching. Think of what this means for our future. Every day, the most distant galaxies are moving further away. Eventually, they will cross a threshold where their light will never be able to reach us again. they will vanish from our sky forever. The speed of light is the tether that connects us to the cosmos, but the expansion of the universe is slowly fraying that tether. The horizon of information. As you rest, contemplate the fact that we live in a very special time. We live in an era where the first light is still visible, where we can still see the evidence of our beginnings. But because light speed is finite and expansion is accelerating, there will come a day, trillions of years from now, when the sky will be truly dark. Future civilizations living in our galaxy will look out and see nothing but blackness. The other galaxies will have been pushed so far away that their light can no longer bridge the gap. They will have no way of knowing that a Big Bang ever happened. They will have no way of knowing that other stars exist. For us, the speed of light gives us a window into the past, but it also creates a clock. Our window is slowly closing. Why is it 299,792? Throughout our journey, we have talked about this specific number, 299,792,458 meters per second. But why that number? Why not faster? Why not slower? If light were just a little bit faster, the universe would have expanded and thinned out too quickly for galaxies to form. If it were a little slower, gravity might have pulled everything back together into a big crunch before life ever had a chance to start. The speed of light is fine-tuned to the other constants of the universe, like the strength of gravity and the mass of the electron. Feynman often mused that this number is one of the great mysteries of physics. We can measure it with incredible precision, but we don't know why the universe chose it. It is as if the universe has a specific frame rate, a speed at which it processes information. Just as a computer has a clock speed that determines how fast it can calculate, our universe has the speed of light, in the harmony of the limit. It is easy to feel small when thinking about 46 billion light-year horizons and the vast expansion of space, but there is a comforting harmony in it. The speed of light ensures that the universe is not an overwhelming, chaotic mess of instant information. Because light takes time to travel, we get to see the history of the universe in layers. We see the nearby planets as they were minutes ago, the nearby stars as they were years ago, and the distant nebula as they were when the Earth was being formed. The speed of light organizes the universe for us. It turns space into a giant library where we can read the story of creation page by page, rather than having the whole book thrown at us at once. The speed of causality in the beginning. Even in those first chaotic moments of the Big Bang, the speed of causality was at work. It determined how fast the first forces could communicate. It determined how quickly the first particles could find each other to form the first atoms. Everything you see around you, the chair you sit on, the air you breathe, the light in your eyes, is the result of 13.8 billion years of interactions that all happened at or below this speed. The speed of light is the cadence of existence. It is the reason the universe has a structure instead of being a blur. A journey toward the present. Let your mind come back from the edge of the observable universe. Come back from the microwave glow of the Big Bang. Come back through the millions of light years, past the distant galaxies, past the swirling nebulae, and back into our own Milky Way. We have seen how the speed of light dictates the past and limits the future. We have seen how it defines the very bubble of reality we live in. But our journey isn't just about the stars and the beginning of time. It is also about the here and the now. It is about how this speed affects the technology we use every day and the very way we perceive the world. As you breathe in the cool air of the present, know that you are at the center of your own observable universe. You are the point from which all your light cones expand. You are the observer that gives the sum over histories its meaning. The silence of the horizon. There is a profound peace in knowing that there are things we can never reach and secrets we can never know. Yes, the cosmic horizon is a reminder that we are part of something so vast it cannot be fully contained by a single mind. The speed of light is the ultimate boundary, but it is also the ultimate bridge. It is what brought the story of the stars to your eyes. In our next chapter, we will bring the speed of light down to Earth. We will look at how this cosmic limit affects our modern world, from the GPS in your phone to the fiber optic cables that carry your messages across the planet. We will see that even in our daily lives, we are constantly dancing with the limit of causality. But for now, let the afterglow of the universe warm your thoughts. The fog has cleared, the light is free, and you are here to see it. Resting in the light as you drift closer to sleep, imagine the CMB, that soft, ancient glow washing over you. It is the oldest thing in the universe, and it is here, in the room with you, touching everything. It is a reminder that you are connected to the very first moment of creation. The universe is vast, and the speed of light is slow compared to its size. But that is what gives us the time to exist. That is what gives us the time to breathe. Rest in the slow, steady pace of the cosmos. The horizon is far away, and you are safe within your bubble of light. Take a moment to think about the phone resting on your nightstand, or the computer you use to connect with the world. We often take these pieces of technology for granted, seeing them as simple tools. But these devices are actually sophisticated laboratories that must account for the most extreme laws of physics just to function. If we ignored the speed of light or the stretching of time, our modern world would quite literally lose its way within minutes. The most famous example of this is the Global Positioning System, or GPS. Whether you are using it to find a new restaurant, track a delivery, or simply see where you are on a map, you are relying on a network of 24 satellites orbiting high above the Earth. These satellites are moving at about 14,000 kilometers per hour, and they are positioned 20,000 kilometers away from the surface. To give you an accurate location, these satellites must synchronize their internal clocks with the clock on your phone to within a few billionths of a second. This is where Einstein's ghosts come out to play. The duel of the clocks. Because the satellites are moving fast relative to you, they experience the time dilation we discussed in Chapter 2. From your perspective on the ground, if the clocks on the satellites are ticking slightly slower, about 7 microseconds every day. This is the effect of special relativity, but there is a second, even stronger effect at play. According to general relativity, gravity also warps time. Because the satellites are much further away from the Earth's mass, they sit in a region of weaker gravity. In weak gravity, time flows faster. For the GPS satellites, this gravitational effect causes their clocks to gain about 45 microseconds every day. When you combine these two effects, the clocks in space are running about 38 microseconds faster than the clocks on Earth. This might sound like a tiny amount, a fraction of a blink, but remember that GPS works by measuring how long it takes a signal traveling at the speed of light to reach you. Light covers 300 meters in a single microsecond. If the engineers didn't build Einstein's equations directly into the satellite software, the location on your phone would drift by more than 10 kilometers every single day. Within a week, the GPS would think you were in a different city entirely. Your phone is a living proof that time is not absolute. The speed of information. The speed of light also sets the rhythm of the internet. When you send a message to someone on the other side of the planet, that information is converted into pulses of light and sent through fiber optic cables buried under the oceans. Even though light is the fastest thing in the universe, the Earth is large enough that we can actually feel the delay. This is what gamers call ping or latency. If you are in New York and you send a command to a server in London, that light has to travel 5,500 kilometers. Even in a perfect vacuum, it would take about 18 milliseconds. Inside the glass of a fiber optic cable, light actually slows down by about 30%, making the trip take closer to 26 milliseconds. We are living at the very limit of what the universe allows. High-frequency traders on Wall Street spend hundreds of millions of dollars to lay straighter cables between cities, just to shave a few milliseconds off the travel time. They are literally racing against the speed of causality, trying to get as close to the 299,792 km/second limit as physics permits. They know that in our world, information is not just power, it is time. The chemistry of gold and light. The speed of light even dictates the colors we see. Have you ever wondered why gold is a warm yellow color, while almost every other metal, like silver or aluminum, is a cold, neutral white? The answer lies in the speed of the electrons inside the gold atom. Gold is a heavy atom with a very large nucleus. To keep from being sucked into the center, the electrons in the inner shells must orbit the nucleus at incredibly high speeds, nearly 50% of the speed of light. Because they are moving so fast, they experience Einstein's length contraction and time dilation. This changes the energy levels of the electrons, causing them to absorb blue light and reflect the warm yellow tones we associate with wealth and beauty. If the speed of light were infinite, gold would look exactly like silver. The very luster of a wedding ring is a relativistic effect, a shimmering reminder that the atoms of our world are bound by the cosmic speed limit. The magnetism in your hands. Even the simple force of magnetism is a side effect of the speed of light. Imagine an electric current flowing through a copper wire. To us, the wire looks electrically neutral, but if you were to move alongside the electrons at their speed, the positive charges in the wire would appear to contract due to special relativity. This slight change in density creates the magnetic force. Every time you use an electric motor, a blender, or a vacuum cleaner, you are utilizing a force that only exists because the universe enforces a maximum speed limit. Magnetism is essentially electricity viewed through the lens of relativity. Without the finite speed of light, the machines that power our civilization would not work. The reality of now. Technology has also forced us to confront a philosophical truth that Einstein first proposed: there is no such thing as simultaneity. In our daily lives, we feel like now is the same for everyone. We think that when we look at a clock, it is the same time for everyone on Earth. But because light takes time to travel, and because time stretches with motion, the universe doesn't have a master clock. If you are talking to an astronaut on Mars, you are experiencing a now that is 20 minutes behind theirs. You are always talking to their past, and they are always talking to yours. There is no way to sync up perfectly. The speed of light creates a causal disconnect that keeps the universe divided into individual perspectives. We are each the center of our own time bubble. The weight of data. As you rest, consider the sheer amount of light moving around you right now. Millions of pulses of data are flying through the air as Wi-Fi signals, bouncing off the walls and racing through the wires in your house. Each one of those pulses is a massless photon, swimming through the Higgs field we discussed earlier, moving at the maximum speed allowed by existence. We have built a civilization that mimics the universe. Just as the universe uses light to communicate between stars, we use light to communicate between minds. Our world is a web of causality, held together by the very limit that Einstein discovered in that Swiss patent office. The limits of tomorrow. Looking forward, our technology is beginning to hit a wall, the same wall that Feynman and Einstein described. As we try to make computer chips smaller and faster, we are running into the problem that signals can only travel so fast across a piece of silicon. The speed of light is starting to limit how fast our computers can think. We are also looking toward the stars. If we ever want to send humans to other planets, we have to deal with the fact that we cannot communicate with them in real time. A doctor on Earth cannot perform remote surgery on an astronaut in the outer solar system because the lag caused by the speed of light would be too great. The universe has built-in delays that we can never overcome. A world of miracles. Instead of seeing these limits as frustrations, try to see them as miracles. The fact that the universe has a speed limit is what allows our world to be stable. It is what allows your GPS to find your home, and what gives gold its color. It is the reason why magnetism works, and why the internet can exist. We are not just living in a universe with a speed limit, we are products of that limit. Every part of our modern life is a conversation with the speed of causality. We have learned to dance on the edge of the absolute, using the very laws that keep us from the stars to make our lives on Earth better. Returning to the quiet. As the thoughts of satellites and fiber optics fade, return to the quiet of your room. You don't need a GPS to know where you are. You are here in the present moment, held steady by the same laws that guide the light through the void. You are a biological machine that also obeys these rules. The electrical signals in your brain, the light entering your eyes, the very atoms in your bones, they are all part of this relativistic masterpiece. You are a localized now, a point of consciousness in a vast web of light and time. In the next chapter, we will leave the world of technology and return to the deep mysteries of the mind. We will look at how the speed of light affects our very perception of reality. We will explore the idea of the light cone of your life, the boundary of everything you have ever seen and everything you will ever be. But for now, let your mind go blank. The satellites are in their orbits, the light is in the cables, and the world is functioning perfectly. You can let go of the how and simply be. The speed of light is handling the rest. The pulse of the present. Feel the slow, rhythmic pulse of your own heart. It is a slow, steady beat in a universe of high-speed vibrations. You are the stillness at the center of the storm. Let the technology of the world fade away and embrace the simple, ancient reality of being alive. The universe is updating itself at 670 million miles per hour. But you are allowed to take your time. You are allowed to move at the speed of a breath. You are safe within the limits of the light. As we move into the 8th chapter of our long journey, we shift from the satellites in the sky to the very shape of your own life. We have seen how light dictates the motion of galaxies and the function of our phones, but now we must look at how it defines the boundary of your personal existence. In the language of physics, this is the geometry of the light cone. Hogo, hogo, hogo. The light cone of your existence and the great elsewhere. Take a moment to center yourself in the quiet of the present. Imagine that you are standing at the center of a vast, dark plain. From the soles of your feet, 2 great cones of light extend into the darkness. One stretches backward into the past, widening as it goes. The other stretches forward into the future, expanding into the unknown. This is not just a poetic image, it is the mathematical reality of your life in 4-dimensional space-time. Because the speed of light is the ultimate speed of causality, it creates a boundary for every living thing. This boundary defines what can ever affect you and what you can ever hope to change. It is the most fundamental structure of your reality, and it is built entirely from the speed of 299,792 kilometers per second. The past light cone, the well of history. The cone that extends behind you is called your past light cone. It contains every event in the history of the universe that could have possibly played a role in bringing you to this exact moment. Think about the light from a star that you saw last night. That star might be 50 light years away. Because the light took 50 years to reach your eyes, that star exists inside your past light cone. The photons from its surface traveled across the void, entering your cone and eventually striking your retina. That star has touched your life. But now, imagine a star that is 20 billion light years away. Because the universe is only 13.8 billion years old, the light from that star has not had enough time to reach Earth. That star is outside your past light cone. For all intents and purposes, it does not exist in your reality. It could explode, it could vanish, it could host 1,000 civilizations, and it would have zero effect on you. You are causally isolated from it. Your past light cone is the collection of everything that the speed of light has allowed to reach you. It is the history that you are allowed to know. Every memory you have, every piece of information you've learned, and every atom in your body came from within this cone. It is your personal heritage from the cosmos. The future light cone. The map of possibility. The cone that stretches ahead of you is your future light cone. It represents the limit of your influence. Imagine you switch on a powerful flashlight and point it at the sky. That beam of light moves outward at the maximum speed allowed by the universe. This expanding sphere of light defines the edge of your future. Shutterstock. Anything that falls inside this cone is a place you could someday visit, or a person you could someday talk to. If you sent a radio message today, it would ripple outward, eventually reaching planets and stars within that cone. But anything outside that cone is forever beyond your reach. If there is a planet 10 light years away and you want to send them a message, they will not receive it for 10 years. You cannot affect that planet now. You can only affect its future. The speed of light ensures that your will and your actions take time to propagate through the universe. You are a pebble dropped into a pond, and the speed of light is the speed at which your ripples move. The great elsewhere. But the most fascinating part of this geometry is what lies between the two cones. This region is known as elsewhere. The elsewhere is the vast majority of the universe. It consists of events that are so far away in space and so close to you in time that light hasn't had the chance to bridge the gap in either direction. You cannot see the elsewhere, and the elsewhere cannot see you. Imagine a supernova happening right now in the Andromeda galaxy. Because Andromeda is 5 million light years away, the news of that explosion won't reach your light cone for 2.5 million years. Right now, that explosion is in your elsewhere. It is not in your past, and it is not in your future. In the classical world of Newton, we thought there was a single now that everyone shared. We thought that if a star exploded, it happened now for everyone. But Einstein showed us that now is a local experience. The elsewhere is a reminder that the universe is not a single synchronized clock. It is a collection of isolated bubbles, each moving at its own pace, only connecting when the speed of light allows them to touch. The protection of causality. As you rest, consider why the universe built these cones. Why not let information travel instantly? Why have an elsewhere at all? The answer brings us back to Richard Feynman and the preservation of causality. If information could travel faster than light, you could step outside your light cone. You could send a message to a point in space and have it arrive before you even sent it, according to some observers. You could, in effect, interfere with your own past. The light cone is the universe's way of keeping the story straight. It ensures that the cause always happens before the effect. It prevents the logical paradoxes that would arise if we could skip across the elsewhere. The speed of light is the glue that keeps the sequence of your life in order. It ensures that you have a yesterday that stays in the past and a tomorrow that waits in the future. The horizon of the mind. This geometric structure doesn't just apply to galaxies. It applies to your thoughts. Every signal in your brain moves at a finite speed. When you decide to move your toe, a signal must travel down your nervous system. That signal is bound by the same laws of physics we've discussed. There is a tiny microscopic light cone for every thought you have. You are a biological creature living within the constraints of a physical universe. But those constraints are what give your life meaning. If everything happened instantly, there would be no process. There would be no learning, no growth, and no journey. The speed of light gives us the gift of the interval, the space between the spark of an idea and its realization. Looking into the void. When you look up at the night sky, you are looking at the edges of your past light cone. You are seeing the history of the universe as it is allowed to be revealed to you. Some of the light you see is old and tired, having traveled for millions of years. Other light is young and vibrant, but you must also realize that for every star you see, there are a billion things in the elsewhere that you cannot see. The universe is much, much larger than our light cones. We are like children looking through a narrow straw at a vast masterpiece. We only see the tiny sliver that the speed of light has delivered to our doorstep. The comfort of the limit. There is a profound peace in accepting the limits of your light cone. You don't have to worry about the entire universe all at once. You are only responsible for what is inside your cone of influence. The events in the elsewhere are beyond your control and beyond your concern. The speed of light acts as a cosmic filter, keeping the overwhelming vastness of existence at a manageable distance. It allows you to focus on your here and your now. It creates a sanctuary of local reality where you can live, breathe, and dream without being crushed by the infinite weight of the simultaneous cosmos. The expanding sphere of you. Every second that passes, your light cones grow. Your past light cone expands by 300,000 kilometers in every direction, bringing more of the universe's history into your awareness. Your future light cone also expands, opening up more possibilities for where your life could go. You are not a static point in space. You are an expanding wave of causality. As you lie there in the dark, your influence is rippling outward at the speed of light. The news of your existence is currently racing past the Moon, past Mars, and out toward the distant planets. You are broadcasting yourself to the stars at 670 million miles per hour. The silence of the space-time. Let the geometry of these cones settle in your mind. Imagine the past cone as a golden funnel, reaching back to the beginning of time, filled with the light of ancient stars and the history of your ancestors. Imagine the future cone as a shimmering blue field of potential, reaching out to the end of the universe. And here you are. At the center. The apex. The point where the past becomes the future. You are the transition. You are the moment where the sum over histories becomes a single, lived reality. The speed of light is the architect of this structure. It is the reason your life has a direction. It is the reason you can look back with memory and forward with hope. It is the most beautiful law of the universe because it creates the space for you to exist. A journey toward the end. We have explored the hills of Florence, the office of Einstein, the diagrams of Feynman, and the geometry of your own life. We have seen how the speed of light is the heartbeat, the weight and the boundary of all things. As we move toward the final chapters of our journey, we will look at the ultimate fate of light and causality. We will ask what happens at the end of time. Does the speed of light stay constant forever? What happens when the last star goes out and the last photon is stretched into nothingness? But for now, stay here in your light cone. Feel the safety of the here. Feel the warmth of the now. You are at the apex of existence, perfectly positioned between the history of the stars and the mystery of the future. Resting in the apex, let your body feel the weight of its own history. Every breath you take is an event in space-time. Every heartbeat is a tick of your local clock. You are in perfect sync with the laws of the universe. The light is moving, the cones are expanding, and the elsewhere is waiting. But you can rest. You have reached the point of absolute stillness in the center of your own cosmic geometry. The speed of light is guarding your boundaries, and the universe is unfolding exactly as it should. Find a place of deep stillness in your mind. Imagine a universe trillions upon trillions of years from now. The stars we see in our sky today have long since burned out. The vibrant nebulae, those nurseries of gas and dust, have been swept away. The galaxies have drifted so far apart that the night sky of any remaining planet is a void of absolute, unbroken blackness. This is the era of the long dark, the final chapter of our cosmic story. In this far-off future, the speed of light remains exactly what it is today, 299,792 kilometers per second. It is the one constant that refuses to fade. But while the speed remains the same, the world it describes has changed. The speed of light, which once acted as a bridge between the stars, will eventually become the messenger of a great and final isolation. The stretching of the message. We have discussed how the universe is expanding, but there is a mysterious force driving this expansion to move faster and faster. Scientists call it dark energy. It acts like a repulsive pressure, pushing the very fabric of space apart. As space stretches, it does something strange to the light traveling through it. Imagine a wave of light moving through the void. As the space beneath that wave expands, the wave itself is stretched out. Its peaks and valleys grow further apart. This is called redshift. A photon that started as high-energy blue light is stretched into red light, then into infrared, then into microwaves, and finally into long, low-energy radio waves. Eventually, the expansion will become so fast and so vast that the light from distant galaxies will be stretched until it has no energy left at all. The news of the rest of the universe will literally fade into a whisper, then into silence. The speed of light is the speed of causality. But when space expands faster than light can cross it, causality itself begins to break. The universe will divide itself into trillions of lonely island universes, each one completely unaware that anything else exists. The era of the black holes. In this distant future, the only light left in the universe will be the faint, ghostly glow of Hawking radiation, the tiny leak of energy we discussed in Chapter 5. As the stars die, they leave behind black holes. For eons, these black holes will be the masters of the cosmos, slowly swallowing the remaining stray atoms of gas and dust. But even black holes are bound by the laws of thermodynamics. Because the speed of light is finite, they must slowly radiate their mass away. This process is unimaginably slow. A black hole with the mass of our Sun would take 10 to the power of 67 years to evaporate. That is a number so large it exceeds the number of atoms in 1 billion galaxies. During these vast stretches of time, the only events in the universe will be the occasional. A lonely click of a photon escaping from the edge of a black hole's event horizon. These final photons will be the last travelers, moving at the cosmic speed limit through a universe that is almost entirely empty. They will be the final witnesses to the structure of space-time. The speed of light in the Great Chill. As the last black holes evaporate in a final microscopic flash of light, the universe enters a state called heat death. This is not a state of fire, but of absolute uniform cold. Everything has reached the same temperature. There are no more differences in energy, which means no more work can be done. No more stars can form, no more thoughts can be had, and no more clocks can tick. In this frozen eternity, the speed of light still exists. It is still the update rate of the universe, but there is nothing left to update. But the clocks that Richard Feynman visualized, the spinning phases of quantum paths, will still be there, but they will all be perfectly synchronized in a state of maximum disorder. Without a difference in energy, time loses its meaning. The interval between two events becomes irrelevant because no events are happening. The speed of light, which was once the conductor of a grand symphony, will be the only sound left in a silent theater, marking a tempo for a song that is already finished. The finality of causality. It is a heavy thought, the idea of a universe ending in cold and silence, but see the beauty in it. The speed of light ensured that the universe had a now and a then. It ensured that the fire of the Big Bang didn't happen all at once and burn out in a microsecond. The finite speed of light is what gave the universe its duration. It acted like a cosmic brake, slowing down the interactions of matter and energy so that 13.8 billion years of history could unfold. It allowed for the complexity of life, the evolution of eyes to see the light and minds to wonder about it. The limit of light was actually the gift of time. Why it matters to you. As you lie in the quiet, you might wonder why the fate of a photon a trillion years from now matters to you today. It matters because it reminds us that we are living in the golden age of the cosmos. We live in a time when the universe is vibrant. The light is still bright enough to see. The galaxies are still close enough to touch with our telescopes. We are the lucky ones who get to exist while the clocks are still ticking at a meaningful pace. We are the observers who give the light its purpose. The speed of light is the reason you can experience this moment. It is the reason you have a heartbeat that follows a sequence. It is the reason the world feels solid and stable. The heat death is the final rest of the universe, but you are in the middle of the heat life, the era of action, movement, and light. The light within. Even as the universe fades in your imagination, bring your focus back to the light within yourself. The electrical pulses moving through your heart, the chemical signals in your brain, they are all governed by the same constants that will govern the last photon. You are a small, warm candle in the vast, cold darkness of the cosmic timeline. Your existence is a brief, beautiful flicker of causality. Yet the speed of light is what holds your atoms together and what brings the world to your senses. It is the ultimate guardian of your reality. The comfort of the end. There is a profound peace in the idea of a final, absolute rest. The universe has been working hard for billions of years. It has built stars and crushed them. It has created life and watched it change. Eventually, it will have finished its work. The speed of light, as the speed of causality, ensures that the story has a logical conclusion. It ensures that the universe doesn't just stop in a glitch, but that it follows its own beautiful mathematical path to the very end. The heat death is simply the universe reaching perfect equilibrium, a state of total unbroken peace. Preparing for the final word. We have traveled from the first flash of the Big Bang to the last flicker of a dying black hole. We have seen how light creates time, mass, and the very boundaries of what we can know. In our final chapter, we will return to the here and the now. We will wrap ourselves in the ultimate realization of what it means to be a creature of light. We will see how Richard Feynman and Albert Einstein gave us a way to find our place in this vast rhythmic masterpiece. But for now, let the cold, distant future fade away. You are not in the era of the long dark. You are here, in the warmth of the present. The light in your room is steady. The air you breathe is full of energy. You are part of the vibrant living middle of the story. Resting in the golden age. Take a deep, slow breath. Feel the life moving through you at its own gentle pace. The universe is expanding, and the stars are burning, and the light is racing at its absolute speed. But you are allowed to be still. You are a child of the light, born in the perfect window of cosmic history. Let the enormity of the future give you a sense of perspective. Your worries, your stresses, your fears, they are all tiny compared to the trillion-year dance of the photons. In the grand timeline, all that matters is the now. The speed of light is keeping watch. The laws of physics are holding the world in place. You can surrender to the stillness, knowing that you are a perfect, finite, and beautiful part of an infinite story. As you drift on the edge of sleep, let the vastness of the cosmos begin to shrink back down to the space around you. Yeah, we have seen that the speed of light is the most important number in the universe. But it is not just a cold piece of data. It is the heartbeat of the void. It is the rhythm that allows the silence of space to become the symphony of reality. Without this limit, there would be no order. With it, there is a grand design that includes everything from the birth of a star to the closing of your eyes. The journey we have taken has shown us that the limit of light is not a restriction. It is the very thing that makes life possible. We often think of boundaries as things that hold us back, but in physics, boundaries are what create structure. A river is only a river because of its banks. A song is only a song because of its tempo. The speed of light is the bank that holds the river of time. And it is the tempo that gives the universe its melody. The legacy of the light. When Richard Feynman looked at his diagrams, he wasn't just doing math. He was seeing the secret language of the world. He realized that the universe is not made of things so much as it is made of interactions. Everything you see is a conversation. Two electrons talk to each other by tossing a photon back and forth. The sun talks to the earth through the light that warms your skin. You talk to the universe through every action you take. The speed of light is the speed of that conversation. It ensures that the universe is coherent. It ensures that when you act, the universe responds in a way that makes sense. It preserves the sacred law of causality, the promise that today leads to tomorrow, and that every effect has a cause. This is the ultimate comfort of physics. The universe is not random. It is not chaotic. It is a structured, logical masterpiece held together by a constant that never wavers. The mirror of the mind. As you lie still, consider the miracle of your own perception. You are a creature made of the very particles we have discussed. The atoms in your body were forged in the hearts of stars, governed by the same E equals mc squared that defines the power of the sun. The electrical signals traveling through your nerves are governed by the same quantum electrodynamics that Feynman mastered. You are not an observer looking at the universe from the outside. You are the universe looking at itself. When you wonder about the speed of light, it is the universe wondering about its own tempo. When you feel the weight of your limbs, it is the universe feeling its own Higgs field. There is no separation between you and the laws of physics. You are the living, breathing manifestation of those laws. The silence of Feynman's clocks. Recall Feynman's clocks, the spinning phases of all possible paths. In the quiet of your room, imagine those trillions of tiny clocks spinning in the vacuum around you. They are the hidden clockwork of reality. They ensure that the light from your lamp travels in a straight line, that the floor beneath you remains solid, and that the stars stay in their places. There is a profound stillness in this realization. Even when you are perfectly still, the universe is vibrant with activity. The sum over histories is happening in every cubic inch of space. The speed of light is constantly filtering the chaos, but turning the infinite maybes of the quantum world into the single, beautiful is of your life. You are the result of a mathematical harmony so complex and so perfect that it defies description. The peace of the absolute. We live in a world that is often loud, fast, and unpredictable. We worry about the future and we regret the past, but the speed of light is a reminder that there are things in this universe that are absolute. It does not matter what is happening in the news or what stresses you are facing. The speed of light remains 299,792,458 meters per second. It is a steady, unmoving anchor in a changing world. Let that number be a source of peace for you. In a world of variables, it is a constant. It is the same for you as it is for the furthest galaxy. It is a shared truth that connects every conscious being in the cosmos. Thus, we are all bound by the same limit, governed by the same rhythm, and protected by the same causality. We are all travelers in the same great light cone. The horizon of sleep, as your thoughts begin to blur and the logic of the day fades into the soft intuition of sleep, let the elsewhere of the universe remain a mystery. You do not need to know everything. You do not need to see beyond the horizon. The speed of light has provided you with enough. It has given you a history you can remember and a future you can imagine. Your light cone is safe. It is a sanctuary of time and space where you can rest. The events outside your cone cannot touch you. The paradoxes of the black hole cannot reach you. You are held in the gentle grip of a geometry that was designed for your existence. The final photon of the mind. Imagine your consciousness as the final photon of our story, a single, pure point of light moving through the void. It is not racing. It is not struggling. It is simply moving at the speed it was meant to move. It is in harmony with the vacuum. It is at home in the dark. As you drift off, let the tempo of your mind slow down. You don't need to update at 670 million miles per hour anymore. You can slow down to the pace of a dream. You can let the clocks of your thoughts stop spinning. The universe will keep moving without you. The light will keep racing. The space will keep expanding. And the fields will keep humming. You can surrender your role as the observer and simply become part of the stillness, the unity of all things. The speed of light is the ultimate proof of our unity. We are all made of the same energy, converted into mass by the same Higgs molasses, and governed by the same relativistic distortions. Whether we are a grain of sand or a supermassive black hole, we are all dancing to the same beat. Einstein found the beauty in the geometry. Feynman found the beauty in the paths. And you have found the beauty in the understanding. You have taken the long journey through the deepest secrets of reality, and you have come back to the simplest truth of all. You are here. You are alive. And you are part of a universe that makes sense. A final breath in the light. Take one last, deep breath. Feel the atoms of oxygen entering your blood. Their electrons interacting with the light in the room in a perfect quantum dance. Feel the weight of the earth beneath you. At a gentle curve in the fabric of space-time that says, you are home. The light is the messenger. The light is the limit. The light is the life. As you close your eyes for the final time tonight, know that the speed of causality is protecting your dreams. Tomorrow will come exactly when it is supposed to, traveling at the speed of light to reach your horizon. You have no need to rush. You have no need to worry. You are exactly where you are meant to be in the four-dimensional map of the cosmos. The infinite rest. The script of the universe is long, and we have only read a few pages. But those pages are enough to know that the story is good. The constants are fixed, the laws are steady, and the light is always moving forward. Rest now, in the heartbeat of the void. Rest in the peace of the absolute. Rest in the knowledge that you are a child of the light, and the light is everywhere. The journey is complete. The sum has been calculated. The clocks have synchronized. Good night from the Sleepy Academy. May your dreams be as vast as the cosmos and as steady as the light.